Oh, Miss P, hi, sweetheart. Good to see you. Ready to go. All right, welcome, grade 10s. Today is Thursday. We are almost done with this week. And today we are going to look at chemical changes. Now, I just want to warn you guys beforehand, okay? The chemical changes that we do is not in a lot of detail, okay? Because if we do it in a lot of detail, I think I might just blow your chemical brains, okay? So we're just going to touch on some of the chemical reactions, okay? So I know some of it might not make sense because you don't yet have the big picture, all right? And as always, you guys know if you miss something, okay, if something goes, whoa, no, man, okay, then all you do is you say, stop, ma'am, please could you go back? Please can we have a look at that again? You guys know that. All right, so here we go. So today we're going to look at different types of chemical reactions, all right? And we're going to talk about the conservation of atoms and mass. Don't panic, okay? It's very logical. I'll explain it to you like, I don't know, we make a sandwich. You guys know me. I tell you a story. Okay. So we get different chemical reactions. We get decomposition reactions. What page? Chiara, you are my lifesaver. Hang on a moment. Page 127 in the Oxford. Has anyone got the study and master page for everybody else? Share it if you've got it. Okay. All right, we're good to go? Right. So we've got decomposition reactions. We've got synthesis. Thanks, Dilo. All right. Chemical change. Wait, ma'am, so we're doing chemical change? Yes, Miss P, we're doing chemical change. Okay. Synthesis reactions. And we do exchange reactions. Okay, iron, good. Ion reactions. Now in grade 10, we don't really look at exchange reactions simply because there's so much that tells us, is an ion exchange going to happen? Is it not going to happen? We get redox reactions. We get acid-base reactions. Okay. Adrian, a redox reaction is not an ions exchange reaction. Okay. Redox reactions are either decomposition or synthesis reactions. Okay. Redox reactions are grade 11 work. They are like insane. I absolutely love them, but there's lots and lots and lots. Do we need to know that? No, Matthew, you don't need to know that. Okay. Here we go. So let's look at how do we know what to name what, okay? So compounds on the left of the arrow, we call reactants. Compounds on the right, we call products. So the things that react are called reactants, and the things that form are called our products. Now, when we have a catalyst, I'll get to a catalyst, or any reaction conditions that we have to think about, we write those on the top and on the bottom of the arrow, okay? Physical and chemical change, yes, dude, this is still part of physical and chemical change. All right, so we had reaction conditions or catalyst, we show it by writing it at the top and the bottom of the arrow. So if you need heat, then you draw a little triangle. If you've got a catalyst, then you normally write what catalyst we're using. Don't panic, I'll show you an example. Okay, now, this is something that I think gets skipped at school level, okay? Makes me very angry. You have to tell me what phase each compound or element is in, okay? So if we think about water at room temperature, it is a liquid. We think about carbon at room temperature, it is a solid. Good job, Aaliyah. Good, you got there quickly. Well done. Okay, so we use symbols in our chemical reaction to show which phase we find the element or the compound in. All right. So if I write a G and I put it in brackets, after a compound, it is a gas. Mbali, I see your question. I'll get to it. Let me just not lose my trend. I got it. I promise. If I write a L, an L in brackets, then it is a liquid. An S in brackets is a solid. Guys, like, can you see how easy this is? No? Then the only one that's a little weird is if I write AQ. Okay? AQ, Aaliyah, good job. Catalyst, it means aqueous, dissolved in water. All right. So if you see any of these symbols in a bracket after a compound or an element, it tells you what phase is that compound or element in. All right. So Mbali's asked a question about catalysts. And Aaron, must they always be in lowercase? Yes, Matthew. Always in lowercase, always in a bracket. Oh, como hello. I'm sorry if I pronounced your name wrong. We are busy with chemical reactions, so chemical change. This is matter material part 2. If you have an Oxford textbook, it is on page 127. And Dilo said, oh, I just need to find it up here. Wait, almost there. Dilo says that in the study and master, it's on page 163 onwards. All right, so this is physical and chemical change. All right, let's get back to catalysts. A catalyst is something that I put into a chemical reaction, okay? But after the chemical reaction has happened, I can take that catalyst out and reuse it. It doesn't get changed. It's the same compound, okay? Why do I use a catalyst? It makes my reactions happen faster, okay? So, sometimes reactions are really, really slow. And if we're doing that in industry, in a factory, then we need some way to make those reactions go faster. Now, the logical thing to do is to put heat in. All right, but we all know what happens when I put heat in. No, it has to be energy. How do I get energy? I ask Eskom. Okay, so if I make the temperature of a reaction very high, then sometimes it costs more to make something than I can get for it. Okay, and so we use catalysts, because a catalyst I can use over and over and over and over again. Okay, so a catalyst is something that makes my reaction go faster. Sometimes it makes it go slow, but that's like very, very seldom. But it doesn't take part in the reaction. Okay, it doesn't get changed when this reaction happens. All right, guys, so that is catalyst. Ironically, you have a catalyst in you. Your body has got lots and lots of enzymes, okay? You would have heard that word when you did digestion in grade 9 NS. Okay, so the enzymes, Matthew, wait, Matthew, okay? Yes, amylase. So the enzymes in your body is a catalyst. Matthew, AQ means aqueous. It means that whatever compound this is behind is dissolved in water, okay? A catalyst is something I add to a reaction to make it go faster. And normally you see the catalyst on top of the arrow. Sandra, go back a slide. Got it? Oh, you're making me go back far. Okay, we're just talking about the 3 different types of reactions. I'm going to go through each of these reactions. Do enzymes denature products? No, enzymes create products. Okay, Bianca, an example of what? Of a catalyst. Yes, okay. So, right, when I make ammonia, you know the stuff, handy Andy bleach, that stuff, okay? Which arrow, the arrow in the reaction, I promise I'll show you. When I make ammonia, okay, it's two gases that come together, okay? And the one of them is nitrogen, and nitrogen is like so bonded, it's got triple bonds, it just doesn't want to react. So what I do is I make the nitrogen and the hydrogen go over a rhodium, it's a metal plate, okay? And the rhodium plate allows the gases to go sit onto the nitrogen, and the hydrogen can now bond with each other, and I get ammonia gas out. But the rhodium plate doesn't react. The rhodium plate is just there to make these two reactants get them in such a way that the two reactants can actually make a new product. Okay. In one of my examples, I do have a catalyst for you. Okay. All right, guys, let's carry on. Pleasure, Bianca. All right, so some phase symbols. Guys, even if your teacher says you don't have to write it, get into the habit of writing it. Okay. So, what do we call the byproducts? In chemistry, we talk about reactants and products. That's it. Okay. All right. So let's look at decomposition reactions. Okay. Decomposition means I start out with a single thing, I do something to it, and then I get two or more small compounds out. Okay. So a reaction, example of a decomposition reaction is hydrogen peroxide. You know, the stuff that makes your hair go blonde and straw. Well, it's not even blonde, it's like yellow. Okay, it strips the color. It decomposes, splits into water, we all know H2O, and oxygen. Okay, so I've got hydrogen peroxide, big molecule, and it turns into water and oxygen. All right, so there's a catalyst. Don't worry about the big numbers at the front right now. I will show you balancing tomorrow. Okay, balancing is what we're doing tomorrow. Okay, and it's important, so I don't want to spend any time trying to worry about it now. Okay, does that mean H2O3? No. H2O2. Okay, that is hydrogen peroxide. Dihydrogen dioxide. Okay, do you know where to split it? You don't have to worry about where to split it. Okay, so balancing equations. Molly, you're thinking about tomorrow. Don't panic. Yo, Miss P, I know this is very confusing. Just whoa and just follow with me. We have hydrogen peroxide, H2O2. It is a liquid. When we make hydrogen peroxide flow over manganese oxide, hydrogen peroxide decomposes and gives us water, which is a liquid, and oxygen. Remember, oxygen is a diatomic gas. So it's O2 and it is a gas. Okay. MnO2 is our catalyst. The catalyst, Arthur, I promise I will explain it a gazillion times. Okay. The catalyst, can you see I don't have manganese oxide this side and I don't get anything manganese-y out. Okay. That means that manganese oxide did not take part in the reaction. It just, manganese is a metal, yeah? Erin! Oh, that's a cool way of putting it. I like that. Can I please use it from now on? Oh, that's a cool way of putting it. Erin says that catalysts are like the divorce lawyers, okay? They're the lawyers. They make things happen faster. I love that, Erin. Oh, you just taught me something. That is so, so, so cool. Okay, manganese is a metal. So, how do you know if it's a liquid or a gas? Okay. Normally it will be told to you. Okay, you don't have to worry about knowing what is what. Okay. Barley, don't panic. Don't panic. Okay. Miss P, I know that was a really good call from Erin. Hey. So just follow again with me, guys. Will they ask us to write this reaction? Not yet. And I promise, after tomorrow, writing this reaction like this will be a breeze. I promise. Okay. Remember when we started, I said it's going to be scary and confusing. Okay. It's because you haven't all figured out how to balance things or why we balance things, why we have a big 2 there, why we have a big 2 there. And that's okay. I promise by the end of tomorrow, if I give you a reaction like this, you are going to be able to balance it like that. Okay. Not every catalyst is a metal, but many of them are. Okay. Sandra, I get that you're confused. I get it. Let's just look at the basics. We've got hydrogen peroxide. It's a liquid. We bubble it over manganese oxide. Manganese oxide helps this hydrogen peroxide split easily without drama, okay? And peroxide, hydrogen peroxide, becomes water and oxygen gas. Okay, so we took a big molecule and we split it into 2 smaller ones. Okay, right. This reaction, manganese dioxide, is the catalyst. Can catalysts be in different states of matter? Yes. Mostly they are solids, okay? But they can be liquids or gases. Okay. Ali, I know. Erin gave us that and it's just flippin' awesome. I'm definitely using it. Oh, Erin, I'm glad we can make you feel appreciated. It's good that we can learn from each other. It's awesome. I love it. Okay. So we have a catalyst. Just as a reminder, a catalyst is a substance that changes the rate of a chemical reaction, but it doesn't get changed. Okay, let's think about a divorce lawyer. Divorce lawyer helps this thing split easily without mess and drama, but the divorce lawyer walks away at the end of the day and he is not changed. Yes, you could get gas catalysts, but like I say, they are few and far between. Most catalysts are solids. Most, not all, most catalysts are solids. Okay, guys? Not quite that scary. Right. The next reaction we're going to look at is synthesis. Okay? Synthesis. So I have reactants. Is it a must that we must say what state the catalyst in? No. Okay, we don't have to say in what state the catalyst in. Catalyst ever pure element? Many of them are. Platinum, rhodium is good catalysts. Okay, so synthesis. I have many reactants and they form a new product. They combine. I synthesize something new. Oi, Judy, will someone give Judy the answer for a catalyst? Now that I've explained it to you guys and Erin has come with a divorce lawyer analogy. Sure, I still think that one is awesome. Okay, so synthesis. And this is one that you guys see a lot. Okay, this is something you guys see a lot. So I have iron and it reacts with oxygen and it forms rust. Arthur wants the definition of a catalyst. Yeah, okay. Quickly screenshot it, dude, while I take a sip of coffee. Done. Got it. Okay. So one that you guys see a lot without realizing it is iron that reacts with oxygen to form rust. You did this reaction in grade 9. I don't think you remember, but you did do it. Okay. So again, whoa, don't panic. Ignore the big numbers in the front. I will teach you the big numbers in the front tomorrow. And we will do it for 45 minutes until everyone can balance. I promise. It is important. And therefore, I will spend time on it. I promise. Okay? So let's look at the basics. I have iron, Fe. It is a solid. It reacts with oxygen. Remember, oxygen diatomic gas. And it forms iron oxide. Is this conservation of mass? Yes, Samson, we're getting to the point of this. Point of the triple I's. Okay, so just like we have the symbols that tell us which state. Mbali, you're going too far ahead. You slow down. Stay with me. Okay? Ollie, are you with me? Just like we write an S or a G or an L, the 3 here tells us how many electrons this metal gave up. Okay, there's a specific name for it. My brain cannot find it right now. I will Google it for you and put it in tomorrow's lesson. Okay, it is the valency, but there's a specific word for it. Okay, there's a very specific word for what they call these 3 things here. Okay, it's not valency, but yes, you are exactly correct. It shows you the valency. Okay, why do we only do it with certain ones? Because lots of elements, we can tell what their valency is going to be from their position on the periodic table. Okay, magnesium, for example. I know magnesium is always going to be +2. It's in group 2. It doesn't have a choice. But iron, good Tamsin, is a transition metal. And transition metals are weird and wonderful, just like you. Okay? And so when we work with a transition metal, we have to tell you how many electrons it gave away. What is the valency of the iron? Okay, so that middle group that everybody tries to put in a box that you can't, they're weird and wonderful. Miss P, valence electrons are the electrons in the outer shell. Amani, you are correct. I'll get you. Well, Miss P, valence electrons are the electrons in the outer shell. Okay, they are not the only electrons someone has or an element has, but they are the electrons that can react. Okay, Leslie, goodness gracious, question from nowhere. All right, so Miss P, valence electrons are the electrons in the outer shell, and they are the electrons that can react. Okay, it's not to say that iron only has 3 electrons. It means that iron has 3 electrons in its outer shell which can react. Okay, all right. Hang on, I got the right answer here. Amani, thank you. That is correct. The IIs here are called stock notation. Okay, but you guys are 100% correct. They show you the valency of this metal. Okay. Ooh, other way. Okay. Good job, Ms. P. I'm glad you get it. Leslie, isotopes, I promise I will get you, okay? But I don't want to break our steam today, okay? Let me see how far we get, and then I will deal with isotopes at the end. Promise. Okay. So, we have an element, and it's reacting. Abigail, we only show the valence for iron Because iron is a transition metal. We only use, thank you Amani, stock notation for transition metals. Oxygen is in group 16 or Roman numeral 6. So we know it has 6 valence electrons. And so we know it needs another 2. Okay? We don't know that about any of the transition metals. Okay? So we only use the stock notation, the valency, for transition metals. Okay? Now, if I have something, anything, and it reacts with oxygen, and it causes heat, we call it a combustion reaction. Okay? The most prevalent combustion reactions that you have in the world is your body. Respiration is a combustion reaction. Okay? But I'm not going to look at respiration because the balancing of respiration is mad. Okay? It's crazy. But hydrogen that burns in oxygen is also a combustion reaction. Okay? Hydrogen burns in oxygen, it forms water, and it creates heat. Okay? Now, this is where life gets confusing because I just told you it's a combustion reaction, right? But it is also a synthesis reaction. Can you see how in chemistry we have so many words to describe the same thing? It all depends on what I'm trying to do with that thing. Okay? Someone asked earlier about redox reactions. Please don't worry about them now. Please, they're like really cool, but they're a lot of work. Okay? And redox reactions could also be a combustion reaction. Okay? So this is where it is important. So combustion causes heat. Combustion produces heat, Erin. Okay. Do we always have to know stock notation of the element? No, actually, they have to give you the stock notation. Okay. They cannot expect you to write reactions using transition metals if they don't give you a stock notation. Okay. Because iron could also be iron 2 and it could also be iron 4. All right. So hydrogen and oxygen. Again, we know that the big numbers are going to pop up. We know the big numbers are scary. We are going to ignore them. Ma'am, wouldn't it rust? How do we know a synthesis reaction is occurring? Mbali, for a synthesis reaction, you have more products, more reactants, and they form one product. Okay? Hydrogen doesn't rust. Rust is a word we very specifically use for iron. Okay. Right. So hydrogen gas plus oxygen gas gives me water. Mbali, did I answer your question though? I know you mistyped. Or I misunderstood, actually, that's better to the point. But Mbali, do you understand how we know there's a synthesis reaction? More reactants, one product. Reactants form something new. I'm not taking something and breaking it up. Okay, Ali, if you wrote an L there, okay, it would be fine. It really would be. This reaction produces a lot of heat, like an insane amount, like your kettle doesn't come close, okay? And that is why we write that it comes out as a vapor, okay? But grade 10 level, they don't put that much emphasis on the state symbols, okay? The problem is that they don't in grade 11 either. And then you get to grade 12 And if it's not there, it's wrong. Okay, that is why I want you guys to get into the habit of thinking, what am I working with? In what state is it? And start getting into the habit of adding it. Okay, right, guys, so we have hydrogen gas and oxygen gas. We combine them and we synthesize, we make water. Okay, is that okay for everybody? Cool. All right, how are they combined? With a lot of heat. Okay, the strange thing is these two, hydrogen and oxygen, need a lot of energy to be combined. A lot. But they give us more energy than comes out. Okay, Ms. P, you say someone doesn't understand. Do I need to scroll back up? Kamal, what don't you understand? Give me like half an indication. Where did I lose you? And don't say everywhere. Ian, just listen. Water is often a liquid, but this reaction produces a lot of heat. Okay, a lot of heat. And so water tends to become a gas. More examples. Guys, tomorrow you are going to get so many examples, like so many examples tomorrow, okay? So I promise you, we are going to do a lot of reactions tomorrow, okay? Ma'am, what is the flame in a combustion reaction called? Does it have a specific name? It is a butane flame, but we don't see the butane flame as being a catalyst. We see it as being heat. So what we rather do, and I think someone mentioned it yesterday, okay, if I heat a reaction, then under the triangle, under the arrow, I put a triangle. Okay, come on. If you wait for tomorrow, that's cool, okay? And then at the end of tomorrow, we take everything together, okay? And I will make sure that there is a summary worksheet for you guys, all right, on the Africa Teen Geeks website, okay? And then we'll take it from there. Hey, there's a Mickey in there. I'm a Mickey too. How do you know that an element is a solid, liquid, gas? Just by looking at the periodic table. Metals are always solids unless it is mercury that is a liquid. Okay, so metals always solid except mercury, which is a liquid, right? All the noble gases are gases. Okay. Your diatomic are gases, H2, N2, O2, F2, Cl2, Br2, and I2. They are all gases, okay? And most of your non-metals are solids. There are very few liquids and there are some gases, okay? Right. All right, Carl, I'm not going to wait for you. How do you separate the equation? Which equation, Sandra? Which equation are you worried about, Sandra? Like the H2O. Sandra, I'm not quite sure I'm understanding you. Okay. Where can mercury be solid in a room temperature? It's not solid at room temperature, dude. Mbali, what was your question, Mbali? I missed it. Type it again. Mbali, quickly type it again. I missed it with all the other conversations going on. Is there a Google Classroom code for science for tomorrow? I'm not using Google Classroom, okay? We, as far as I know, are using Zoom. So the Zoom code will be the same. All right. And then for the Google Drive, you go to Africa Teen Geeks, you go to Lockdown eSchool, and then you find all the resources there. Rusting is an example of a synthesis reaction. Yes. Combustion occurs, meaning it is a synthesis reaction. Yes. Mercury, I don't know. Okay. Arthur, no, mercury cannot be solid and a liquid. How do I get the Zoom code if I just use the link? Use the same link. Any science test during lockdown? I'm going to give you a end of section 1. Okay. Carl, we are doing decomposition and synthesis reaction. Mbali, I can't scroll up. Where am I going to scroll up to? Okay. Someone will just tell me what Mbali asked, because now I'm having to like find here. Okay, I answered that question for Mbali. Mbali says yes. Goodness. That's not Mbali's question. Oh, wait. If combustion occurs, does it mean it is a synthesis reaction? Yes. Yes, Mbali, yes. Thank you for helping me out. Okay. Yes, there is always a lot going on, Ollie. How do you think I feel? All right, Lee, don't panic. I'm not giving you a test for marks. Calm down. Okay, all right. So, this is synthesis reactions. All right. Now. Yesterday we spoke about energy, hey guys? And we spoke about energy in terms of physical changes. Arthur, panic. I can give you a test to do for yourself and give you the memo, okay? But you don't have to write a test for me. That is not what this is about. Sandra, what are you confuzzled about? Sandra, are you confused about the, oh, sweetheart. Okay, Sandra, send me a private message what you're really struggling with. Okay, all right. So, exothermic and endothermic Miss P, you jumped to it. Okay, yeah. When I want to break bonds, I need energy. And when new bonds are formed, they release energy. Yes, we don't have to do exchange reactions in grade 10. Okay. When I want to break bonds, I need energy. When I form new bonds, I get energy. Carol, it's all on africateengeeks.co.za. Okay. Sometimes some reactions require more energy than I get out. Sandra, I see what your problem is. I will deal with it tomorrow. Okay, I get exactly where you are. I promise I see exactly what the problem is. You said it exactly right. Okay. Ma'am, can't you talk slow? No, I have ADHD. Okay. So, focus. Some reactions need more energy than I get out. Okay. They are called endothermic reactions. I know they are endothermic because when I hold the beaker, it gets cold. Other reactions release more energy. Exothermic, good. Now, my easy way of remembering this, and I apologize if you are not Christian or if you are devoutly Christian and you feel that I am attacking you, okay, I apologize. This is how I can remember it. So, in Exodus, the book Exodus, the Jews are sent out. and they are sent out into the desert, into a really, really, really hot place. And so exothermic reactions release, give away energy, and they become very hot. Endo, I take in, internal, endo, so it becomes mine. The reaction takes heat. Okay. All right. Okay. Again, guys, I don't need to try and offend anyone. Okay, it's the same thing when I explain the periodic table to you guys. It is my little stories for me to remember these little stories. Okay, I struggle to remember facts, so I make stories like this. Okay, that's how I got to the periodic table story. Okay, all right, cool. So exothermic and endothermic. When I have a reaction, any reaction, any reaction, to break the bonds of the reactants, I have to put energy in. When new bonds are formed, so when the products are formed, the bonds that they make release energy. But this doesn't always happen in equal measure. So some reactions, I need to put more energy in that gets released when the products are made. They are called endothermic. Example of endothermic. I'll give you lots of examples of exothermic reactions. You guys remember a while ago with exothermic reactions, there was this little water or little patch thingy, and it was jelly, and then you clicked a button, and then it got hot and solid. Okay, those little heaty pads. That is an exothermic reaction. You also get ice packs, right? Where it's a liquid and you squish it and then it goes cold. And that is an endothermic reaction. So again, if I have to put more energy in than I get out, the solution or the beaker becomes cold, and it's called an endothermic reaction. If I get more energy out, then the beaker becomes hot, and it is an exothermic reaction. Sorry, Carl. Okay. Endo gets cold, goes in. Exo gets hot, releases energy. Okay. Cool. Now, stop. I am not going to do conservation today. I will do it tomorrow. We've got like 3 minutes left. I'm not going to try 2 minutes. I'm not going to try and rush through it. Okay. So we're not going to do conservation of mass. We are not going to look at the electron transfer stuff like that. Not today. Okay. You guys have done such a fantastic job. I know your brains are hurting. I can see it. Okay. You are doing such a fantastic job. I can only imagine how hard it is to learn like this. And I take my hats off to you for doing it this way. Dilo, I don't know if I want to see something cool. Okay. And those of you who are, oh, okay, I can do that. That's cool. Those of you who are asking, yes, I am ADHD. I have no issue in telling it to anyone. Okay. I am ADHD. I take Ritalin because it works for me. I'm not saying that everybody has to take Ritalin. Now, yes, you are correct. Okay. It works for me. Right. But It means that when you guys lose attention, I have empathy, I understand. Okay. All right, guys. Aren't teachers working harder too? We are working very hard. Okay, very, very hard at the moment. All right. But I'm an adult. You guys are not. And the fact that you're putting as much effort in as you are, I take my hat off to you. I'm so respectful. And guys, I enjoy working with you. Okay. I pitch up every day with a smile. I'm excited. Okay. Because you make me excited. So we're going to keep on doing this in the sucky lockdown. Okay. Right. Until we can get to go outside and enjoy our freedom. Yes, Miss P, especially you. Actually, no, everyone who comments. I really enjoy having you in here. All right, guys, I will see you tomorrow. We will do conservation of mass, law of conservation of matter. And then if we have to do balancing next week, we do balancing next week. We do balancing next week. Okay. All right. And then tomorrow I'll give you a plan for next week. Okay. Don't panic. I've got you. Guys, have a fantastic day. Good luck with maths. Bye.